evening, students. This is Manas Patnaik, your friend and tutor. And in today's one-shot video, we are going to be solving all the questions that had appeared in December 2022 engineering graphics paper from the University of Mumbai. This is going to be fun. And before we start solving all the questions one by one, let us first strategize. How do we do that? We are going to browse through all the questions, and I am going to follow this EAT philosophy. The questions which are easier, okay, I'll categorize them. Questions which are average and questions that fall in the tough category. The first thing is, take a look at this question number 1. This is for 15 marks. And by the way, the maximum marks is 60 and the time limit is 3 hours. And I'm sure you can finish this paper in 2.5 hours. I'm sure anyone who has learned thoroughly all the concepts, all the chapters of their syllabus, they can solve the paper in 2.5 hours, not more. Okay. Anyway, so the first question 1 is from the topic of sectional orthographic, and I am going to keep this in the tough category. Yes, it has to be kept in the tough category. There are 4 things which have been asked. You need to make the sectional front view. Okay, you are going to assume that a cutting plane is passing through this line over here, and then you need to remove the front portion. You need to create the front view. That is your sectional front view. You also need to create the top view and the right hand side view. That means looking from here, you need to get that view. Once that is done, you need to place as many as 10 dimensions. I always suggest my students, if you've been asked to put 10 dimensions, put at least 11 to 12 dimensions. Okay, so this is in the tough category, sectional orthographic. Second question has got 2 parts. Part 1 is having 6 marks, whereas part 2 is having 9 marks. Part 1 is easy, and this is from the chapter of projection of solids. Part 2, I would say this is in the tough category, and this is from the chapter of isometric drawings or isometric views. Okay, but still this can be done. Okay, so do watch the solution. I'm sure all of you can, especially whenever there are problems based on isometric, whenever there is a circular profile, students are hesitant to attempt that problem, but it can be worked out. You'll see it in the solution. Okay, it may take some time initially, but I'm sure you can work it out. So this looks like a potential attempt for all of us. Question number 2. Okay, we can go for this. Question number 3 is from the chapter of orthographic projection, and I'll keep this in the easy category. It's a very easy problem. You just need to make the front and the top view. So damn easy. Put the dimensions as many as 6 in number. Then we come to the second part, or the part B of question number 3, and this is from the chapter of engineering curves. There is a topic called Involute, and I am going to keep this in the average category. Okay, why average? Why not easy? The reason being very simple. You have been given the string length. In this case, if you work out, the length of string is actually going to work out as lesser than the circle's circumference. Whenever this is the case, it can be the reverse case also, where the length of string is more than pi d. Okay, in both the cases, in fact, there is a certain element of confusion that creeps inside the head of students, because most of the students who actually learn just before the examinations, 5 days or 10 days before the examinations, they attempt the general case of involute, where the length of string is equal to the circle circumference. This is a slightly complicated case, a slightly advanced case. Therefore, attempt this question only when you have previously attempted similar questions. Okay, do watch the solution also. It's fun, and I'm sure after watching the solution, you are going to be in very good position to crack any problem based on involute. Don't worry. Question number 4 is from the chapter projection of solid. I'll keep this in the tough category, but again, this can be cracked. Although I am keeping it in the tough category, yet this can be cracked. To watch the solution. Question number 5, do not attempt. Most of the people are going to get this wrong. Do not attempt. Khatre ki ghanti hai ye. Although the problem is from the chapter of projection of lines, and they have clearly written that use first angle method of projection, yet this problem, the line in this problem find itself in the 4th quadrant. Okay, it's not going to be that easy, let me tell you very, very honestly. Right? The question looks very simple. It appears as if, yaar, ye to bahut aasan hai, to koi bhi bana lega, but no, it is not. The students who have learned the concepts of projection of lines very, very deeply only they will be able to crack it, and you'll watch the solution. Okay, I have got the entire 3D representation of the line in this particular case, right? Do not attempt. खतरे की घंटी है एकदम strict no. Question number 6 है बिल्कुल बनाना चाहिए. You should attempt it. I'll keep this in the average category, and this over here I'll keep it in the easy category. तो question number 6 के part A and B, you must attempt them. Must attempt them. Question number 4 also can be attempted. Let me use a different color. Question number 6 should be attempted. Question number 4 should be attempted. Question number 3 even should be attempted. Yes, you should. And now you can make a choice. Either you can go for question number 2, or you can go for question number 4. Okay, or question number 1, right? I think I've made myself absolutely clear which questions are tougher, which ones are easier, which ones are average. That is my choice. Okay, because I've read all the chapters, I've taught all of those chapters. I know which questions are easier, which ones are going to take lesser time. And once you watch the solution, you will also get a fair idea as to how to go about your task. Now, as far as the PDF notes of all of this solution to different problems is concerned, you can access them through my application. The link to download and install my application is in the description down below. Go ahead, install the application. Once the application is installed, you just need to go to the course section. Inside that, you'll find different courses of engineering mechanics, drawing, AutoCAD, SolidWorks. Go to the engineering drawing course. Inside that, there are different folders. Let me just browse you very quickly through them. There is a folder of engineering drawing English lectures, folder of engineering drawing Hindi lectures. Both of them are there. Different chapters. Almost, the chapters does not matter which university you are from. All the chapters have been covered thoroughly. There is a special folder, university-wise folder. I'll talk about it. PDF notes are there. Okay. The PDF notes that you want, it is somewhere else. Worksheets, MCQ type problems, right? All of them are there. Full length objective test. In fact, if you start watching the lectures, it will take you more than 1 month. Even at an increased speed, you would need a lot of time. Anyway, the last folder is university-wise content. Click on it. You are going to have as many as 3 options. Pune University, Mumbai University, Hyderabad. Go to Mumbai University folder. Again, inside this folder, there are these lectures, right? Chapter-wise. Let me go inside this. And by the way, I've kept these lectures in Hindi for Mumbai University. If you want the English lectures also, do let me know. Inside this, go to previous year's question paper. Here you are going to find 2 folders, May 2022 and December 2022. This particular question paper, one short video that we'll be discussing in today's video, is for December 2022. Click on this folder, and here you'll find the PDF. This has been kept unlocked for all my subscribers on YouTube. Whether subscribed or not, it's for you. Don't worry. Okay. So this is for you. The moment you click on it, automatically a PDF will pop up, and this PDF can only be accessed through your cell phones. Right. So that's the entire solution. I think I have spoken a lot, and if we've made the strategy, now let's crack each and every problem in detail in this video. And here we go. Question number 1, December 2022, engineering graphics paper from the University of Mumbai. And here we go. Let's check this out. So we have been given the pictorial representation of an object, and what we need to do, we need to create the front, right hand side and the top view. But the front view is slightly different. It is a sectional front view. So you need to cut the object along this line, this section AA. Okay. One more thing. I have made a virtual model in AutoCAD. Let me show that to you. This is how the object looks, and to basically check out the features, we'll be rotating the object. Even we'll be cutting the object, slicing the object, and then we are going to prepare the sectional front views. Okay. But how to do this manually, I'll be demonstrating all of that. Don't worry. I think we can now shift to the question. Here it is. Here we go. So the first thing is, there are 4 things which have been asked in the question. Number 1 is the sectional front view along the section AA. If you take a careful look, this line is where you need to slice the object into 2 equal halves. You have to go for a full section, as the section starts here and ends here. So the entire object will be cut, the front portion will be removed, and then whatever you see from over here, that is by default your sectional front view. Whatever you see from the top qualifies as the top view. Whatever you see from the right hand side qualifies as the right hand side view. And also you need to insert some dimensions. Please note that all the 4 things which have been asked in the question have some marks associated: 5, 4, 4 and 2. If you add all of them, this constitutes 15 marks. So 15 marks can be fetched out of 60 directly from this one single problem. It is a bit typical, but I'm sure in the next 15 to 20 minutes we can crack this very, very easily. Here we go. Shall we begin? Okay, here we go. First of all, I want all of you to take a look at this 3D arrangement. Take a look at all the features. Can I pause this? Okay, if you observe carefully, this portion looks like a cylindrical tube, okay, hollow from inside, having an inner radius and an outer radius. All the dimensions have been given, don't worry. This portion ahead of this profile in front is of 8 millimeters, whereas this portion at the back is 18 millimeters. So there is a difference. Initially, when I was creating the CAD model, I actually assumed that the portion over here is 18, so in front also it has got to be 18, but that is not the case. The tube is a bit eccentric, so please remember, don't commit the same mistake that I did. Okay, let me resume this. Keep watching. What we'll do now is we are going to have a cutting plane, popularly known as a section plane, and let me get the section plane passing through the center. Exactly. What you see over here, the portion of the object which has come into contact with the section plane is what is known as a section. This grayish portion is what is known as the section, and you need to draw the section from watching the object from over here. Okay, this is your front on, right, as far as the problem description is concerned. So front, the section can be seen, and hence we call this a sectional front view. Let me resume the video. Take a look again. This basically is going to be your sectional front view. Okay, I think it would be better if we can just take a picture of the sectional front view. Let's take a picture of the sectional front view, and let me take you to the next slide. Now we need to determine the maximum length, the maximum width, and the maximum height of the object. For that, let me take you to this figure. Listen to whatever I say very, very carefully. This is going to be very important because we are going to be following the box approach. Okay, so here, in fact, in any problem, you have a front view, you have a top view. Over to the right of front view, you have the left hand side view. Please note this. And over to the left of front view, you have the right hand side view. What do we need to make, sir? We need to make the section front view, the top view, and the right hand side view. So this is going to be our approach layout. This is going to be our layout. I hope you guys understand this very, very well. Okay, if we were supposed to draw the left hand side view, then our layout would have been this, right? I hope you understand this. What is the maximum width? Sir, this is the length, this is the width, and that's the height. Again, this is the length, width, and the height. Sir, the maximum width is 70. So this is very easy to determine. Second, what's the maximum length? Sir, maximum length is also very easy. If you watch, this distance is 40. This distance is 18. And in between, this distance is, radius is 15. So that's 15 to the left of the center, and that's 15 to the right of the center. This in fact is 30. 30 plus 40 is 70. 70 plus 18 is 88. So the length happens to be 80, right? We all need this. The width is 70. Sir, but what about the height? The height also can be determined very easily. Take a look. What is the exact vertical distance between the center? And if I call this the base plate, okay, the bottom of the base plate is here. This is the bottom of the base plate. From the center to the bottom of the base plate, it's 48. What about this? Sir, this is having a length of 18. The reason is very simple. This happens to be the radius also. So the diameter of the larger circle is 36. Therefore, the radius is going to be 18. Simple. Done. So far, as far as the height department is concerned, we know one thing, that it is going to be 18 plus this 48. What else? What else can you add to this? Sir, what we can do is, we need to add this much also. Should I zoom in? How can you find this out? Sir, actually this is 26. If we subtract 18 from it, this will be 28 minus 26 minus 18 is 8. So this is going to be 8. So plus 8. What's next? And if you watch this distance, the remaining, this is 15. So let me add 15 to it. You just need to add all of them, sum them up. 18 plus 48 plus 8 plus 15. This works out as 89. Okay, so there you go. The length is 88, width is 70, whereas the height is going to be 89. So now the approach is very clear. We need to start by making 3 zones. This zone is for the front view, and as I have told you before, that's the top view. Right hand side view is always to the left of front view. Okay, now what were the datas? Length is 88, height is 89, width is 70. So in the front, what you see is this length 88, height is 89. Done. This again is the length, which is 88. This in the top view, you see the width. Width, we worked it out as 70, as you can see. Once you have both of these boxes, you can make this right hand side view box very easily by simply extending these lines towards the left, and then these lines towards this partition line, and then rotating them at an angle of 45 degrees. Okay, and then producing them in the upward direction. The intersection, that's the intersection. These are the intersection. So these are the corner points of the box for the right hand side view. I hope this is clear to everyone. And by the way, this is the first question. It's typical. When I teach this subject in a very formal way, we go through all the concepts very, very carefully. If you want to learn from the basics, you must enroll in my course on my application, the engineering, drawing, engineering, graphics course. Does not matter which university of India you come from, this is going to benefit you a lot. And please remember, your first year of engineering is very, very important. If there is a backlog, there is a star on your mark sheet. That does not augur good for your future. Make sure you pass your engineering with no backlogs as such. And this subject, once they receive a backlog, I mean, you take it to the second semester, already there is a load of 5 to 6 subjects, and then plus 1 more, okay, or 2 more or 3 more. If there are backlogs, you won't have a good frame of mind. Positivity will get away from your life. And please note, I mean, let's say this. I am sure all of you would agree that backlogs create a very, very bad atmosphere, even amongst friends and families. Okay, so try to work this subject out, and this can be worked out very, very easily. It's not a difficult subject. Students make it difficult because they don't start learning from the basics. Once you do that, you'll start getting the results. Okay, and that's why I say, if you want to learn graphics, enroll in my course ASAP. Okay, let's resume. Now you know how all of these boxes can be created. What we want to do is, we want to start creating the front view. By the way, I'll initially create the front view, then I'll do the section. Okay, and that's what you call the section front view. This is the approach that I'll be following. It's a non-conventional approach, but I'm sure you'll understand. Okay, so how do we start? This is for the front. That is for the right hand side. This is for the top. How do we start? What you can do basically is try looking for this very point. Okay, so how do we know the exact location of this point? Sir, from the bottom it is at a height of 15, and from the leftmost corner, this is not the leftmost edge. The leftmost edge is this over here. That is 18 plus this is going to be 15. 18 plus 15 is 33. So if I were to give you the coordinates, it is going to be, this is 33, and from the bottom, this is 15. I hope you can mark this point. And please, whenever you make these center lines are where you see a circular profile, please make a plus sign and then extend it to the east, west, the north and south, right, in the chain form. Done, sir. Now what? Now what you can do is from this point over here, this is the point I'm talking about. That is the line 56. That is the line 56. Again, this line over here, this curved portion that you see will look like a vertical line from over here. Okay, this curved portion will rather look like a vertical line. The line's length is going to be 36. So this is going to be 36 in totality. 36. Done. That's 56. That's 36. You know this. Secondly, please keep this calculation inside your head. If the diameter of the outer circle is 36, what is the radius? Sir, it's 18. Okay. Inner circle's radius, sir, the diameter is 18. Therefore, the radius is half, 9. So 18 minus 9, outer radius minus inner radius will give you the thickness of this tube. R outer. If I were to calculate the R, outer radius, it is going to work out as 18. Inner radius is going to work out as 9. The thickness of the tube can be worked out as R outer minus R inner, which is going to be equal to 18 minus 9, which eventually will work out as 9 mm. So you can say this thickness over here is 9 and this thickness over here is 9. So 9 mm below and 9 mm above, you are going to make these sort of dashed lines. Why? Because this is an inner circle. Okay, it goes behind 56 millimeters. It goes behind 56 millimeters. That is why we have done this. So in order to show hidden features, what you can do is you make use of such dashed lines. Over and out. Clear to everyone? Then take a look at this point. Where is this point or this point? So right at the center. To be very precise, they are somewhere here. Okay. How do you find these points, sir? It's very simple. And one more thing I forgot to mention is this line. What is this length? Sir, this length is actually 18. This over here. This length is actually 8. So you can make these lines very easily. Okay, all the dimensions have been given. Now what you need to do is you need to drop 2 lines vertically in the downward direction. Sir, but again the problem is, what is this length? We can work out this length. Let me zoom into this. Zoom out slightly. Okay. From the center to the base of the plate, 48. Minus the thickness of the plate. 48 minus 10 will give you 38. Minus this 8, 30. So this distance, okay, right from the center line to the bottom, it is 30. So you need to travel this distance of 30. This is 30 and this has to work out as 30, right? This in totality is 56, out of which this much is 18, this much is 8, so 18, 8, 26, and this is 56. This is remaining. This has got to be, how much did I say? 30. Okay, very easy. Now how do we proceed now? Again, if you watch, let me take you back. From here, go in the downward direction. This is 26. This again is 8, not 18. This is 8. 26, 8. Now we are here. This is 40, sir. Go here. This is, sir, this is 10 down. Then this, how much? Sir, 40 again. So we are almost done with the front view. Let me make a few more additions. Okay. Sir, this is 26. When you subtract 18 from it, the answer is 8. Okay. 26 minus 18 is 8. So this much distance over here is 8. So, or what you can do is simply make a vertical line through this point until it reaches the center line over here. Done. Now you can see this arc is having a radius of 15. So with this as center, with this much as the radius, make an arc. Radius is 15. Done. Sir, this inner circle is having diameter of 15. So the radius is going to be 7.5. This is how you need to make it. Done. That's the front view, not the section front view. We are yet to do the section, right? I'm I'm following a sort of unconventional approach. You can straight away start making the section front view. I rather want to show you what happens when you initially start with a front view. Then you see there are so many hidden features which have been represented by dashed lines. In order to get rid of that, what we do is a section, and then how beautifully you can see the inside of the entire machine component. That is the idea. Okay, so please don't mind. Now what you are going to do is, these are the important points, okay, and through them you can draw lines, right, like this and this, both horizontally and vertically. These are the projectors which will act as guidelines. Okay, they are going to help us create the top view as well as the right hand side view, both. There is one more thing which I would like to show you. This over here, this edge, again can't be seen directly from over here. It is hidden, therefore a dashed line. How far is this, sir? This is 15 plus 10. That means it is 25. Done. All right. Let's finish this in the next 5 to 10 minutes, not more. Now let's make the top view, sir. Okay. Sir, this line over here is exactly at the center, like this, isn't it? Yes, sir, it is. What to do then? What we can do is we can make this center line. Okay. We can make this center line. Okay, done. Then, sir, we know we have to sort of make a rectangle over here. You see, this is 56, this is 36. So we can make this rectangle. This is 56, this is 36, isn't it? Okay, and that's the beauty. Again, this is the inner radius, and its extension behind cannot be seen. Therefore, it is a hidden feature. I hope you guys can understand this very easily. What is the next thing that you are going to do? So the next thing is, if you watch, these are the points that we are interested in. What we are doing right now is we are making the top view. In the top view, these 2 points will be, please, I am referring to the front view also. These are the crucial points for me. Okay, these are the points that I am talking about. If I say this as 1, 2, this is 1, 2, this is 1, 2. Okay, and through them, what you can do is you can make these lines, these lines, these lines. Just do it. Done. Okay, now just close it. Close it. This is what I made. Done. Okay, sir. Now what? Now you see again a hidden feature. Draw it. Done, sir. Now what? Now what you can do is, we are here. Okay, you go this way, go this way, and here also. How much is this? Sir, we can work it out. So do work it out. So this is 70, out of which this radius is 10. So this is 10 over to this side, to the right hand side, and to the left hand side. Make it 20. 70 minus 20 is 50. Half of 50 is 25 over here, and then 25 over here. Okay, please note, 25 plus this 20 is 45, plus 25 again, it is going to be 70. So that's 25. 25, you reach here, and from here again you go in the upward direction, stop at 25. Now again the work is simple. This is 15. Can I zoom in? That's 15. Here it is. Mark the center. Now with a radius of 10 millimeters, make the arc, semicircular arc. Done. Easy. Top view is also done. Now what we will do is, you can make all the lines. It rather gets crowded. I am interested in the crucial ones. Rotate at an angle of 45 degrees, project it upwards, and yeah, now we can begin. Now we wish to see how the object looks from the right hand side. The first thing, the outlines from over here, bottommost, make it. Done, sir. This over here, this arc would look like a line, isn't it? A vertical line simply. This arc over here would look like a vertical line. So what you can do is, this arc, I think this is the arc. Just watch. This is the arc. It would look like a line, and then there is a straight vertical line. So this is the arc, and then a straight vertical line. So this projector over here will help you to stop right here and here. I mean, this is the reason we drew these guidelines. Done. Okay, sir. Secondly, what you can see, this thickness over here. How much is this thickness? This can be worked out. Again, you can take this as the reference. Okay, so make a hidden line, then a center line. Very easy. Both of these center lines are at the same level. You can now understand this. Then, sir, one more thing. If you watch, I mean, there has to be one more hidden line, a dashed line. Okay, corresponding to this, you've made a dashed line. So here also, you should make a dashed line, but I haven't. The reason being very simple, not very simple rather. The reason is that the line thickness that I have given is 1.5. Okay, so try to listen this. What is happening over here? That there is an edge. There is an edge through this very point. That edge and the hidden line from over here, they are extremely close to each other. There is a difference of 0.5 millimeters only, right? So the thickness is actually gets overlapped with it. That is the reason. It is possible when you make it with pencil, these things may not happen. What I'm trying to say essentially is that this solid line and then there just 0.5 millimeters below, you are going to have a line like this. Okay, attached line. So you can see, you could see the difference. I'm not exactly sure, but yes, on my diagram, it is not showing. Anyway, don't worry about it. Tension nahi lene ka. Let's move ahead. What is the next thing, sir, that we can do? The next thing is, from where are you watching? Sir, from the right hand side. Where is this center? So here it is. You can extend this and then we can make a line like this. This is going to be the exact location of the center, and here it is. Here it is. That's the center. And by the way, what about these lines, sir? What have we just done? You can make these boxes. These boxes are having a height of 10 millimeters. So 10 millimeter side. Give it some height. Done. And then locate the center through the center. Sir, this is having a radius of 9. Sir, this is having a radius of 18. Do it. Make these concentric circles. Done. Now the task is very easy. In the front. Okay. This is for the front. 1, 2. Let me write it like this. 1, 2. But when you look at it from over here, right hand side, this is going to be 1. Let me put a dash also. Double dash, 2, double dash. Can you understand? This one single point represents 2 points. One at the front, one at the back. Okay. So you need to come downwards 30 mm below. This distance we know very well, it is 30. So I mean, you can take this line as the reference. Okay. Come 30 down, then this way to the extreme left, this way, this way, this way, and then you can obviously close it down. And finally, as far as the section is concerned, let me talk about it. I mean, what we really want is the portion of the cutting plane. Cutting plane passes through this section line. Okay. So this tube is being cut into half. So when it is being cut into half, this is the portion which needs to be sectioned. Yes, sir. Agreed. This portion in the middle. Yes, agreed. Then this entire tube over here. Okay, right to the back. It has the same cross section. So this also will come into the picture. When you take all of these things into account, you can make the hatching like this. And when you do the hatching, please note, please everybody note that these solid lines have to be removed. Okay, because they were part of the front view. You are making the section view. Even these hidden lines, remove them. This is how the diagram would look finally. And want to see some magic? Let me bring this over to this side. Okay, before I show you the magic, please note that all the construction work should be done very, very lightly. This is how your work should look. And in fact, while making these hatching lines, make use of a pencil which is sort of has a grayish tint or a grayish color. Keep it very light. 2H pencil, I would suggest you guys, at an angle of 45 degrees. This is how the section looks. And finally, let me show you some magic. Okay, this is the pic that we took from AutoCAD, and it fits in perfectly with our own created drawing. Looking good. Okay, and we were also asked to show the dimensions, at least 10 dimensions. So here they are. The font size is a bit bigger so that you guys can look at these dimensions clearly. That is why I've kept a bigger font size. In examinations or whenever you are doing some manual drafting, keep it between 3 to 5 millimeters, not more. Okay, as far as the font size is concerned, this is what I'm talking about, font size, right? Yeah, that was the problem. Okay, I hope you have found this entire demonstration to be very, very helpful, efficient, and effective. Please share this video with all of your friends and classmates, and so that they can also benefit. And if you've got any doubt in engineering, drawing, or mechanics, do send your questions to me directly on my application through the chat box. Okay, don't hesitate to send questions. So don't worry. Thank you. All right, so the next problem is based on a cylinder and not on this infant formula. Okay, so in the next problem, we've been given a cylinder which has been kept in a particular position, for which we'll be drawing the front view and the top view. This is going to be very interesting as it is a one-step problem, and I want all of you to pay attention. And here we go. Let's switch to the problem description, and then I'll demonstrate all of this to you very, very beautifully. Don't worry. Okay, this is going to be fun. Let's start reading the problem first of all. Here we go. So we have a cylinder. The diameter is 50. Axis is 65 long, lying on HP on its curved surface. Lying on HP on its curved surface, with its axis inclined at 45 degree to VP. So the axis is inclined to VP and parallel to HP. Okay, it's very clear. If it is lying on HP, okay, then does not matter what angle it makes with the vertical plane, it is going to stay parallel to the HP. That is for sure. I'll give you proper reasons for it. Okay, with some very good demonstrations. So do watch the video entirely. Draw the projections of the cylinder. Let's straight away write down the data which have been provided in the question. Number 1, the dimensions of the cylinder. Here they are. Base is 50 diameter. Radius is 25. Okay, sir. Length of the axis is 65. So this is 25 radius. Center. The distance between them is the axis length. That's 65. And please note that it is lying on its curved surface. Lying on the curved surface, sir, iska kya matlab hota hai? How would it look if it is lying on its curved surface on HP is written? So it is going to be something like this. Okay, axis starts here, axis ends here. And does not matter if you keep it like this, the axis still remains parallel to HP. If you keep it like this, it is still parallel to HP. If you keep it like this, it is still parallel to HP. Does not matter. Okay, rotate it entire 360 degrees, you will note that axis is always parallel to HP. Now, we also have been given in the question that the axis is inclined at an angle of 45 degrees to the VP. Sir, it is a two-step problem. This is something that we can easily work out. But what should be our step number 1? Just wait. Let me set it up for you. Let's say this writing pad, it becomes our vertical plane. Agreed? Okay. Let me keep my phone over here. Girna mat bhai tu. Okay. This is the cylinder can. Now, we've been clearly stated that axis is inclined at 45 degrees to the VP. And before that, it has been said that it is lying on its curved surface on HP. Okay, let me switch to the full screen mode. Here we go. So this is now lying on its curved surface. Okay, if the axis is making 45 degrees to the VP, the case is like this. Let me show you from the top. This is how the case is. You can see the axis starts here and it ends somewhere here. if you extend this line further, it is going to cut the vertical plane somewhere here. दिख रहा है सबको? Okay. Now try to imagine this. Here the angle will be made with the VP. This angle is 45 degrees. This is what has been given in the question. Please remember the standard procedure that I taught all of you in the first lecture of my playlist from projection of solids. If the axis is making any angle either with HP or VP, here in this case it is making an angle of 45 degrees with the vertical plane. Okay. For step number 1, your initial assumption is going to be like this. Keep it perpendicular. Keep the axis perpendicular to the vertical plane. Step number 2, step number 1. Step number 2, step number 1. So when I say axis is perpendicular, you can see this starting point of the axis, ending point of the axis somewhere here. Okay, right at the center. And if you simply try to extend this line, take a look at this line. This is the axis. If you extend this line, produce this line, it is going to meet this vertical plane somewhere here, and the angle made, okay, try to imagine this, is going to be 90 degrees for sure. Now, when this is the case, this is going to be your initial assumption for step number 1, and in step number 2, you can incline the axis. Okay, let's talk about step number 1. The question that I'm going to ask all of you is, from where can you see the true shape of the base? Sir, the base is right here. So from where can you see the true shape? Sir, we can see the true shape of the base from the front. And therefore, you have to begin by creating the front view first. Okay. And please, what is this? Sir, this is the horizontal plane. So, और पीछे चले जाऊं क्या मैं? Okay. What is this then? Sir, this is the XY line. Basically, you need to make sure that in your drawing, the bottom of the circle is touching the XY line. In the front view, the horizontal plane looks like an edge, isn't it? This is that edge. You can say it so. Okay. So now I think we can definitely begin. And in step number 2, we are going to do it like this, making an angle of 45 degrees. And this is what you'll see. Let me discuss this out also. This portion is clearly visible. Yes, sir. This outline is also purely visible. Yes, sir. This outline is also purely visible. Yes, sir. And this outline, yes, sir. This is also visible. So what's not visible? This outline is not visible at the back. This one is not visible for the front view. And this is what has been asked in the question, right? So something which is not visible, sir, it is a hidden feature. How do you represent it? Sir, we represent it using dashed lines. So lagana padega dashed line. And then also don't forget to make the center, not the center, but make the axis, okay, which connects the two centers, one at the front, one at the back. I think enough talking. Let's straight away get to the solution of the problem and बनाते हैं इसको. चलो कैसे बनाए पर चलते हैं यहाँ पे and let's start. True shape of the base can be seen from the front, okay, like this. We are keeping in touch with the XY line, which in a way indicates that the cylinder is in touch with the horizontal plane. समझ गया? Okay. So are there any corners in the cylinder? No, sir, there are no corners. What can you do? Sir, we can generate our own imaginary corners. How? We can divide the cylinder into 8 parts. The front of the cylinder, that means the front circle, and the back circle, like this. इतना कर लोगे भाई, 8 parts में divide. Okay. Now, as far as the front part is concerned, again, let me take you to the demonstration once again. As far as the front part is concerned, what we are going to do is we are going to number it by alphabets, okay, and the back portion we are going to number it, name it by numbers, okay, represent the back by numbers. Like in the front portion, what we'll do is, let me show this to you. A B C D E F G H. A B C रुक जा, ठहर जा. A B C D E. समझ गए बंधु? Okay. Similarly, we are going to start from here, 1 2 3 and so on at the back. So you can do this very easy. It's right. Okay. Let's take a look at it from the top. When you take a look at it from the top, what do you see? Sir, from the top, what we see is a simple rectangle, nothing else. It is a clear-cut case of a rectangle, isn't it? What do you see? Sir, we see a rectangle. How much is this? Sir, this is 65. The axis is beneath it, right? This is 65. Okay. So let me implement this very, very quickly. Here we go. At any random distance, this distance can be taken as 1 centimeter, let's say 10 millimeter, by the way. This is what you need to do. This is 65 millimeters. Can you do this? And these are what you call the generators of the cylinder. Step number 1 is almost done, and what you really need to do is to make these points. Let me show this to you. For example, take a look. These are for alphabets at the front, these are for numbers at the back. As far as alphabets are concerned, A, H, then just below H there is B. That is why along with H we have written B. Then G, just below G there is C. So GC. In the same fashion, there are the same representation as at the back. I hope you can understand this very, very easily. Now in the next step, what we'll do is we are going to go for the axis inclination. Okay. Do you want to see the realistic look again? Here it is. This is, what is this? Sir, this is step number 1. What did you do in step number 1? Sir, we kept the axis at an angle of 90 degree with the VP. Okay. So in step number 2, what we'll do is we're going to go for the rotation. Here, the axis now makes an angle of 45 degrees with the vertical plane. This is what we'll see. So basically what you need to do is, this was your top view from step number 1. Okay. You have to remake this top view into step number 2. But you need to rotate it at an angle of 45 degrees. So how can this be accomplished? And this is going to be your final front view. This is what we are going to make finally. Don't worry. बनाए इसको. Okay. आ जाओ. अब हो गया यार. अब ऑब्जेक्ट और नहीं दिखाएंगे. मैं अभी भावनाओं में बह जाता हूँ. All right. Please remember one thing. If the how shall I put this? If the axis makes an angle of theta with either the HP or VP, then in that case, the base is going to make an angle of 90 minus theta. So in this case, sir, here the axis is making an angle of 45 degrees with the vertical plane. So obviously 90 minus theta, that is 45, will give you the value again as 45. This is a coincidence. In case of 45 degrees, we get both the angles, both axis and base as 45. Okay, not in any other case. It's a rarity. So what we'll do is we are going to recreate this line over here, but at an angle of 45 degrees. You need to do this. Okay, these same points, let me tell you very, very honestly, these same points have to be marked first of all using the compass. Once that is done, the next step is going to be very, very simple. You need to take use of your mini drafter, keep it like this into this position, and then tighten the screw, drafter lock, get your drafter to E, F, D, G, C and HB, and start drawing lines using this scale over here like this. Yes sir, this is very easy. Okay, complete it. So what we've basically done is we have copy and pasted top view from step 1 into step 2. The one thing that we've kept in mind is that we have rotated it as well at an angle of 45 degrees. So please note here, we kept the base at an angle of 45 degrees. If you want to extend the axis, you'll realize the axis also makes an angle of 45 degrees. Okay, once this is done, now time to have some fun. Let's have the lines from the bottom to the top and from the left to the right, and the intersection points. For example, 7 and 3 are going to lie along this vertical line. 7, that's the location. 3, that's the location. In the same fashion, you can find the remaining points. As I told you, what you can see is this. Let me show this to you once again. ये दिखेगा भाई आपको, ये दिख रहा है. Okay, this is what you can see, and let me take you back to the main diagram. This is what you can see clearly. Try to visualize this inside your head, right? And sir, this outline is also visible. दिखता क्या outline? हाँ जी, बना दो. Please check this. Sir, this curved portion is also visible. दिखता क्या? bana do. Sir, this outline is also visible at the bottom. So create it. Sir, whatever is left, whatever features are left also has to be given respect. Although we cannot see them directly because there is this portion which is at the back, which you cannot see. This portion you can see, but this portion you cannot see. Therefore, you have to give it respect in the form of hidden lines, or dashed lines, right? And I've also made the axis, if you noticed. Okay, so the question is almost done. Now let me take you back to the main diagram. Okay, what's next? Students, keep in mind that all of these construction lines, that is, the projectors, have to be kept very, very light. So keep it like this. And secondly, you need to dimension. The diameter was given as 50, mentioned. The length of the axis is 65. That is also mentioned. And if you want to take a realistic look at the drawing, it would look something like this, realistically. Okay, that's the entire drawing. I hope everyone watching this video have now got a good grasp. Even by just watching this video, you now have a good grasp as to how such problems can be tackled, right? Now let's switch to problem 2b. This is based on an isometric drawing and it's one of my favorite topics. Very interesting question. Do watch this right till the end. And one small piece of suggestion for all of you. For this very problem, that is question number 2b, do watch this entire video in one go. You can also increase the speed of the video to 1.25x, no problem, but do watch this video uninterrupted. Once you have seen the entire solution, then take your sheets out, drawing sheets out, or you can switch over to AutoCAD also, and then you can make the drawing. Okay, but see this video uninterrupted and observe the entire process, how it is implemented. Okay, watch very carefully. Here we go. So we have to draw the isometric view of an object whose front view and top view are being given. Let us try to work out the maximum length, width and height and all of that stuff. Okay, let me take you to the main slide. Here we go. If you observe carefully, this entire product is a combination or a blend or is a sum or a union of two components. One component is here. This is sort of having a slant surface, whereas this component is having a hole drilled. Okay, the inner and outside diameters are being given. The outside is having a radius of 30, whereas the inside circle is having a diameter of 30. The diameter is 30, the radius is going to be half of it, that is 15. So make sure you implement all of these things. Okay, sometimes we may end up mistaking diameter for radius and vice versa, so don't do that. Okay, as I've said, that this product looks like a combination of two machine components, one the slant surface and one with a hole drilled. What we'll do is we are going to make these components separately. We are going to kick off with this slant surface component and then we will switch to this hole component. Okay, so let's say right now I'm interested in this very component. It is having a maximum length of 40 plus 20. Can you see this? Yes, sir. And this component, same component in the top view, you can see that it is having a width of 60. Again, length is 60, the width is 60. And once we draw the length and width in our isometric drawing, then gradually we'll be giving the heights to all the respective points. No problem. Let's go ahead. Number one thing, the first thing to do in case of any isometric drawing is you have to make the isometric axis. Let me draw this in rough. These are the isometric drawing axis that you guys need to draw. This angle over here is 30. That's 30. Again, this is 90. Obviously, this is 90. And in between these two, the angle has got to be automatically 120 degrees. Do you agree with me? Yes, sir. So any line that you make on your isometric drawing, which is parallel to either this or this line, is an isometric line. Okay, and all of these isometric lines combination sort of gives birth to an isometric drawing, sort of. Okay, but there are non-isometric lines also, which we'll be encountering in a short while. Don't worry. So the first thing to do is to make a point. Okay, sir. What is this, sir? This is 60. What is this? This is also 60. 60 to the right, 60 to the left. Again, these lines are isometric lines, right? You can start by simply making these lines at an angle of 30 degrees. So these are the two isometric lines. The other isometric line is going to be along this vertical direction. No problem. Okay, so that's the first thing. You can finish this. You can keep your drafter like this. You can then tighten the screw, bring it over here to this very point, draw a line again. Okay, and then repeat the same stuff. Make another parallel line with respect to this from this point over here. Done, sir. Now what we'll do is, if you watch carefully, I am going to make this profile, sort of zigzag profile. Okay, I'm going to finish it, and then gradually we'll be giving the height to all the points. If you observe, this is 60 and this is 16. 60 minus 16 is how much? So it is 44. 44, that means this plus this is 44. Therefore, this has to be 22 and this has to be 22. 22 plus 22 is 54 plus 16. What did I just say? 22 plus 22 is 44 and plus 16 will give you the value as 60. So this has got to be 22. This also has got to be 22. Okay, we understand this, sir. But what about this line? How do you know the dimension of this line? Well, this has already been given in the problem. If you watch carefully, this is actually this line. Okay, so you have to move towards the left by a distance of 20, right? So this distance over here is 20. Whatever you do right now, make sure you are using a 4H pencil. It has to be extremely light. Only you can see the construction. Okay, nobody else, right? So once your entire drawing is done, what we'll do is we are going to override it with the help of an H pencil. Okay, so that your isometric looks very nice and very professional. Okay, sir. Now this is done. Now what we'll do is we are going to create this profile, and it's very easy. Let me tell you. Okay, you just need to know what the dimensions are. What about this dimension, sir? This is given as 65. So from over here and even here also, you can draw this line 65. How much, sir? This is 65. Done. Very easy, sir. What's next? What about this, sir? This is not given, but we can work out. Sir, this is 65. This is 50. 65 minus 50 will give the value as 15. 15. So this over here is 15. This also is 15. Yes, sir. Very easy. So right now we are positioned at this very point. Okay, and this is the same profile to the back also. Don't worry. How much is this, sir? This is 20. It is given in the problem. If you can't see it, let me zoom in. What is this? 20 to the right. So you have to move parallelly with respect to this line. 20 along this direction. How much? 20. Done. Okay. How much is this? 15, sir. Already implemented. Now simply join these 2 points. These 2 points. Okay. Like a slant. Right. This is a non-isometric lines. All the lines. This is a non-isometric lines. This also is a non-isometric lines, and all the other lines are isometric in nature, right? Non-iso. Whereas the remaining lines, all of them fall in the isometric category. So don't worry about it. Join quickly. 7 minutes over. Let me finish this in the next 10 minutes. I just shot a video in Hindi. There it took me around 20 to 25 minutes. Let's see if this video in English can beat that. Okay. Be more efficient. In order to bring more clarity to the drawing, let me remove these edges, as they won't be seen. Why they won't be seen? Because they fall behind a surface, okay, or a face. Let me remove them. Okay, clarity given. Right. Now what? Take a look at this profile. Let me zoom in. When do you create a dashed line? Sir, a dashed line is used to represent hidden edges. That essentially means that there is a hidden edge. There is a hidden edge over here and here. That is the idea. And this edge's height, sir, we don't know what the height is, but we do know that the foot of this edge is at a distance of 20 from the right hand side. Foot of the edge edge is at a distance of 20 from the rightmost point. That essentially means that the foot of the edge, this is the foot of the edge, is at a distance of 20 from the right hand side. So at a distance of 20, simply produce a line in the vertical direction until it intersects this slant surface. Until it intersects this slant surface. This slant surface. Lovely, isn't it? And now you can extend it, draw a line, parallel line like this. Again, a lot of mini drafter uses there. If you don't have access to a drafter, use a roller scale. I mean, without these tools, you won't be able to create such professional drawings. Okay, sir, all good. Now what? These 2 points are at the top also and at the bottom also. They are at the top also, they are at the bottom also. I am concerned with the bottom 2 points. What is this height, sir? The height is not given. Don't give a damn about the height, because you already know it is going to end somewhere here. Okay, that is what we are going to do. Easy. Now students, what you need to do is you need to keep your drafter again along this non-isometric line, tighten the screw, bring it over to this point, draw a line, bring it over to this point, draw a line. Done. Okay, sir, join it. Done, sir. Now what? Now I am going to remove the unwanted lines, and the moment I do that, my drawing is going to come alive just like this. Samjha sabhi ko? Okay, come alive. It pops out. Okay, looks beautiful to the eye. Right? Done. Now what, sir? So sir, this component is something that you have cracked very easily. We would love to know how this component now can be created. The component with a hole inside it can be done very easily. Follow the steps. If you watch, there is this flat surface over here. Can you create this flat surface? So this can be created. What we need is, if you watch carefully, 60 overall. Minus 30 will give you 30. That means this plus this is 30. Half it. 15 plus 15 is 30. Plus 30 will be 60. So 15 plus 15. So what we'll do, at a distance of 15, just a second, at a distance of 15 from over here, we are going to make a point, rather make a line like this. Okay, similarly, I mean, this is 15, this is 15. Done. Easy, no problem. Okay, let us now focus our complete attention onto this profile. How can this be worked out? Can be done rather very easily. How should I begin? Take a look now. Keep your drafter aligned along this line. Tighten the screw, bring it over here, draw a line. Okay, just a bit of, I've removed some construction just to give you more clarity. Okay, sir. How do we proceed from here? What we'll do is, right now we are situated here. Okay. Please let me know how much is this distance. Sir, this is 30 minus 20, that is 10. This is 10. By the way, there is no edge over here. This is simply the extension line, which is used for dimensioning basically. 10 millimeters towards the right, and then you need to travel in the downward direction until you intersect this slant surface. 10 millimeters to the right, you've reached here. And then go in the downward direction until you intersect the slant surface somewhere here. Done. Okay, sir. Now in reality there is no edge over here already. Although I have made a line, I don't need it. I'm going to remove this. I'm also going to chip off this portion. Okay, so let me remove them. Done. Okay, sir. So far so good. Right now we are stationed here. Try to relate to both the drawings. From here, you need to travel in the upper direction. How much is this? Do we know how much this is? Can you work out? Sir, this can be worked out if you watch. 30, okay, plus 30, 60, okay, plus 15 is 75. So 75 in total from the top to the bottom. Minus 65 will give you 10. So, sir, if you want to reach this point over here, you need to travel 10 millimeters in the upward direction. So from here, 10 millimeters in the upward direction, 10 millimeters. Done. Yes, sir, we've reached. Okay. Now, sorry, you need to travel along this distance. 30, 30, 30, 30. Wonderful. Okay. So far, so good. अब कैसे आगे बढ़े? Now what you need to do is, by the way, we are here. Okay. I am going to make this plus sign in isometric. Watch. This outer circle, not circle, a semicircle, is having a radius of 30. How much? 30. 30 and 30. 30 to the right, 30 to the left. Let's try to create this semicircle. Okay. Here we go. 30. Something is left. थोड़ा थोड़ा मैं भूल जाता हूँ एनिमेशन कब क्या किया है. Okay, let me finish this. How much is this? Sir, this is 30. So 30 to the right. Join it. And then 30. 30 again. Done. Okay. Now, travel 30 in the downward direction. You'll reach here. Let me show this. 30 in the downward direction here. Again 30 in the downward direction. Okay. Now, to the left, and then to the right. 30 millimeters. All of them, in fact. Isometric plus. This is the orthographic plus. This is the isometric plus. Okay. I hope you are able to relate to all of these things. What's next? Enclose this in a box. Can you do this? You just continue to make your drafter aligned along this line. Make parallel lines like this. Then drafter along this line. Make parallel lines like this. It will automatically get enclosed and it would look something like this. Right? Looks like a rhombus, isn't it? Yes. The rhombus is having two diagonals, larger and smaller. Focus on the endpoints of the smaller diagonals. Okay, sir. The next step is from these two endpoints, make lines and connect it with the midpoint of opposite side. Like this is the opposite side and this is the opposite side. These are their midpoints. Connect it. From here also connect it. Okay. So far so good. Now with this as the center and with this much as the radius, rotate. Now with this as the center and this much as the radius, use a compass by the way, rounder, rotate. Again with this as the center and with this much as the radius, rotate. You don't need to rotate. Why? The reason being very simple. Why are you intent on creating a full circle? What you really need is just a semicircle. So stop. No need to proceed and remove the construction. You guys don't have to remove the construction, but I have to. नहीं तो पूरा गरम मसाला हो जाएगा, समझ में नहीं आएगा कि दालचीनी किधर है, जीरा किधर है. समझ में आया? Okay, I have to. Okay, sir. So far so good. Now, our focus is on this. How much? What about this plus? And what is the radius over here? Sir, the circle, smaller circle, is having a diameter of 30. That means the radius is going to be 15. 15 to the left, 15 to the right, 15 upwards, 15 downwards. And let me implement this. Here we go. 15 ऊपर, 15 नीचे, 15 दाएं, 15 बाएं. हो गया. ठीक है जी. Enclose this in a box. Same approach. From here onto the midpoint of the opposite two sides. Produce two lines. And from here onto the midpoint of the opposite two sides. Now start making the circle. Center, radius, rotate. Done, sir. Center, and that's the radius. Rotate again. Finish it off. Center, radius, rotate. Center, radius. Use a compass. One leg at this very point and the pencil leg over here. Rotate, and voila. What you have is a beautiful isometric circle. Done. हो गया. तो construction अब मैं हटा रहा हूँ. I am removing the construction. Here we go. Okay, sir. What to do next now? Because this semicircular profile will be here also, sir. And then we are going to join it like a tangent. And then only our work will look, I mean, like an isometric drawing. Otherwise not. So how to finish it off? How to give the finishing touches? How far is this From this point, how far is this point? Sir, it is 30 millimeters. This is also 30, 30, 30, 30, 30, 30, 30, 30, 30. All of these lines which I have just made, all of these lines which I have just made are 30 millimeters long. And these lines have been made from the circumference of this sort of circle over here. Okay. So you are getting points. These are the different points that you got, right? Small piece of advice for all of you. Don't make lines like this. Rather, keep your drafter, first of all, aligned along this edge, tighten the screw, nut ka slow, and then bring it to this point. Don't draw a line, but rather make a point. Just make a point. No need to draw lines. Similarly, then select another point beside it. Make another point over here, right? But the drafter should be along this direction. Please make sure. Once your drafter goes down, 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 and once it reaches a point that it almost becomes a tangent to the curve, then you've got to stop. Okay, that is going to be your final point. And then when you join all of these points in proper sequence, what you have is a beautiful curve like this. Can you see the curve? Okay. You don't have to do the entire construction at the back or at a distance of 30 millimeters behind. No need to do that. Save your time. And finally, your isometric drawing should look like this. That's the final drawing. 20 minutes down. Maza aa gaya sawal demonstrate karke, and this was fun. Okay, but not that easy by any stretch of imagination. This is for a 9 marks. Question number 2A was for 6 marks. That problem, question number 2A, what was it based on? That was based on projection of solids. That will take you around 15-20 minutes. This is going to take you around half an hour. So yeah, 45 minutes, maybe 1 hour for an average guy, right? So time lagega, but once you make this entire diagram, it is so damn satisfying. Question number 3A, let me tell you very honestly, it is a bonus problem. If this ever appears in your examination in the future, do attempt it, because this can be done. The complete drawing can be made in the next 10 minutes. Okay, here we go. Question number 3A, and this is basically for 9 marks. Okay, the pictorial view of a machine part is shown in the figure. You need to draw the front view from the direction of X. Where is this X direction? Here it is. It is as if you are looking from here, and then from here you need to make the top view. That is the first thing. How many marks? 4 marks. Secondly, you need to create the top view. That means you have to view it from the top. That's how you get the top view. And also you need to plug in 6 dimensions. At least कम से कम 6 dimensions. ज़्यादा तो कितना भी हो सकता है. ठीक है? At least 6 dimensions. So do it. If you do that, you're going to very easily fetch 9 marks. Let me take you to the problem. And first of all, what we'll do is we'll try to work out what the length, width, and the height is. If you look carefully, this over here represents the length. How much is the length? Sir, length happens to be 90. Very well. This happens to be the width. How much is the width? Sir, it is 25 plus 25, that is 50, and plus 40 will give you the value as 90. Length and width, both of them happen to be 90 millimeters each. What about the height, sir? Height again can be worked out very easily. This over here represents the height. How much is the height? Sir, height is given as 70. So whenever we start any problem on orthographic projection, we draw an XY line, isn't it? Yes. And then we draw a box like this. Okay. And in this box, you've got the length and the height. This basically represents the front view. Similarly, on the same line, we also make one more box, which is for the top view. Top view. Again, you have access to the length and the width. You know very well what the width is. Sir, it is 70. How much is the height? Sir, it is 90. How much is the length? Did I do something wrong? The width is 90. The height is 70. The length is 90. The length is 90. So this way you need to make box, and I have made it just for you guys. Here it is. Can this be done? And take this as, let's say, 10 millimeters. This also has 10 millimeters. All good? And there is a small issue with the problem. I'll talk about it in a short while. First of all, take a look at this point. This point. How far is this point? The distance between these two points is 30. So take 30 millimeters to the left. Okay, stop now. We are placed somewhere here. Here. We started from this very point and we are here. Now the problem is, how far in the downward direction do we need to go? We don't know. Can this be worked out from the given dimensions? No. The reason being very simple. You have been given this total height of 70. Have you been given the height of this edge? No, sir, we have not been given. So what I did in order to work out its a dimension, I took this drawing to AutoCAD and I tried to simply create a line between these 2 points and also between these 2 points. Fortunately, the length of the line worked out as equal, which essentially means if this line over here has 25 dimension, this also will have a dimension of 25. So now you can work out if this over here represents a dimension of 25. So 70 minus 25 is definitely going to give you this value as 45 millimeters. Now you know. Okay, so a dimension was missing. And let me tell you something. When a teacher makes a question paper, I mean, in the note section, I've always seen they write this thing down. Assume suitable dimension if necessary. I mean, this, I think it's a misuse. It's an absolute misuse of this note. All the dimensions should be mentioned. Whenever you prepare a question paper, it should be checked by other professors also. Okay, so that such mistakes are not created, right? The dimension should have been given. Okay, it creates confusion in the minds of thousands of students who are writing this paper, and it eventually results in wastage of time. So that's not good, right? We should focus on making very robust, unquestionable question papers, if I can say so. Okay, now, so you need to move in the downward direction by a distance of, this is 45, and we've reached here. Then take the left and go as far as you can. Okay, or rather I should say go left until it intersects this vertical line. Then in the downward direction this way, then towards the right, then in the upward direction, and close it. So the L shape has been created. This L shape has been created. Now what? Second thing is, if you see this point, the distance between these 2 points is 30 millimeters. So what you need to do is, from over here at a distance of 30 millimeters, you need to make a point, and through this is what you'll see. The projection of these 2 slant edges will be visible to you from the front. So the projection will look absolutely vertical like this, and then we are going to finish it off like this. Done. Front view is almost done with a few additional dashed lines. Let me talk about that. If you watch carefully, this is 25. So let me zoom in. This is a hidden feature and hidden edge. It has to be given respect and should be represented by a dashed line in the orthographic projection. By the way, to be very honest with you, this is that edge I am talking about. This is the edge I am talking about, right? It is falling behind a face, right? That's why. So 25 millimeters below, draw this dashed line. Secondly, if you watch, through this very point, there is another edge which goes behind. Okay, and the length of that edge also happens to be 90 millimeters. So this is that edge, right? In the front view, you'll see this edge or this point of the edge is at a height of 15 millimeters. So from this baseline, 15 millimeters above, you can make this dashed line which represents an hidden edge. Done. So the front view is done. Now you can make these guidelines. It is going to help you. What is this? What did I just do? Sir, you've darkened the edges. Why? What you see? This in orthographic, this in pictorial, this in orthographic, this in pictorial. Keep watching. This in orthographic, this in pictorial, this in pictorial, this in pictorial. Okay, and in the same fashion, you can understand why I have made these also as dark solid lines. Secondly, can you see this? Yes, sir, we can see this. Oh, forget about it. Can you see this? This, and this. It will look like as if there is one single straight line. In the same fashion, this also will look like a single straight line. Okay, so far so good. Top view is almost done. with a few additional dashed lines. Where are they? We have got to do some calculations. This in totality is 90. Minus 60 will give the value as 30. So half of 30, that is 15, is over here, and the remaining 15 is here. So from this very edge, at a distance of, in the top view I'm talking about, at a distance of 15, there is a hidden line. Again, at a distance of 15, there is another hidden line, dashed line, basically 15, 15. Okay, here it is. This is 15. This is 15 from both the edges. This is the hidden line I'm talking about. Got it? You can see this box. Okay, so at a distance of 30, you can make this point and then draw a line. Similarly, at a distance of 30, you can make this point and draw this line. And this is the hidden line. The other thing is, if you watch, there is this edge. Again, it falls below this face. All the faces, in fact, can't be seen directly. It's a hidden feature. How far is it from the back portion? 25. How far is it from the front portion? 25. So from here, 25 mm below. In the same fashion, from here, 25 mm above. That's 25. That's 25. Done. We are done with the top view. Okay, and finally, when you give it the dimensions, we've been asked to put at least 6 dimensions, right? So I have more than 6 dimensions. You can take a look. Okay, the construction lines have been lightened, right? I can darken and lighten them because I'm working on a virtual screen. You guys can't if you're making a manual drawing. So start the drawing always with a 3H or a 4H pencil. Keep your work very light and then overwrite using an H pencil, and that's the bottom line. Right. Thank you very much, and keep watching all the other problems also. They're also very interesting. Now, let's shift our focus to question number 3, part B. And this is based on an involute. Take a look. And this is for 6 marks. Okay. One end of a string AB of length 140 millimeter. Listen to this very, very carefully. Is wound around a disc of diameter 50 millimeters by keeping one end A fixed on the disc. Okay. And keeping the string always tight. Wonderful. Draw the locus traced by the other end of the string and name the curve. Let me straight away take you to the solution, and this will be over in the next 5 to 10 minutes. And I would strongly suggest you guys that you draw it on a piece of paper, A4 size piece of paper, or a bigger chart sheet. Okay, your choice. There is a string. What is the length of that string? Sir, it is 140. Write it down. Secondly, it has to be wound around a disc of diameter 50 millimeters. So the disc diameter is 50. Wonderful. Whenever you come across any problem on involute, try to work out whether it is a general case or it is a comparative case. When I say general case, if there is nothing written in the question about the string length, then you can straight away assume that length of the string is equal to the circumference of the circle. When there is specifically mentioned that the length of string is so and so, in that case you need to make a comparison whether the length of string is less than the circle circumference or the length of the string is greater than the circle circumference. All of these things have to be taken into account. So let us calculate pi d now. On working it out, we see that it is 157.07, and here is the length of string. Can you compare? You can clearly see that this length of string is lesser than the circumference. And let me write it down. How to begin our construction? Does not matter if the length of string is less than or even greater than what? The circle circumference, that is pi d. The initial construction steps remains same. Don't worry. Let me just show this to you. What we'll do initially is we'll start off by making a circle of diameter. The diameter is 50, but the radius r is going to be 25. Can you do this? Yes, sir, we can. Secondly, can you divide the circle into 4 equal parts? Yes, sir. Can you divide each of these parts into 3 equal parts? 3, 3, 3, 3, which makes the total division of 12. Okay. And now let's number them. Starting from this very point, 1 dash, 2 dash, 3 dash, and so on. Done, sir. So far, so good. Very easy. Okay. In the next step, we are going to make a line. Sir, what is the length of this line? It is equal to pi d. How much is pi d? As you saw in the previous slide, it is equal to 157.07 approximated 157.1. Okay. You cannot mark 157.07 through your physical scale, right? Okay. Now, how many divisions did you go for in this circle? Sir, we actually did 12 divisions. Therefore, or you must go for 12 divisions along this line also. Okay, if you go for 8 divisions over here, you have to go for 8 divisions along this line. If you go for 12 divisions along the circle, you have to go for 12 divisions along the line. That's the funda. So we are going to start off with this point, and let me randomly draw any line at any angle, no matter what. Now, keep your scale over here and at equal distances of 10 millimeters or 1 centimeter, keep on marking points. Okay, how far are these 2 points spaced? Sir, 1 centimeter. Then again 1 centimeter. Then again 1 centimeter. I have put up arcs, but you can simply make points. No need to make arcs. How many arcs? 12 arcs. Now, connect this 12th arc with the end point of the line in this fashion. And now it is the job of the drafter. How can I make this properly? You need to keep the longer scale of your drafter over here. Then tighten the screw. Okay, then move your drafter to this 11th point, draw a line, 10th point, draw a line. Keep on repeating this process until all the points have been exhausted. Done. Now we are going to start the numbering. It starts from over here, 1, 2, 3, and so on. Can you do this? Yes, sir. This is the initial construction phase, which remains same for both the cases. Does not matter whether the length of string is less than pi d or it is greater than pi d. This is the initial construction step, which is same. Now we are going to put our string along this line over here. What is the string length? So string length is 140 millimeters. Okay, starting from this point, keep your string. This is 140. Okay, can you mark this point? I've used a different color. You guys won't be able to use different colors. Simply write a point as written in the problem. Let me show this to you. In the problem, it was clearly written that end A has to be fixed on the disk. Okay, while the other end, this other end of the string, that you'll hold it and then you'll keep on wounding the string, right, until the process finishes. So that is exactly what you'll do. Let me go back to this main slide. And now what, sir? There is a specific reason why this point has been marked as 1 dash and not this point. What is that reason? If you just try to think this logically, let me zoom into this. This AB string is what we are concerned about. We want to wound this string around this disk on the circumference of the disk. So what will happen when this much portion of the string is wound? The remaining portion can be retained or can be shown with the help of this tangent, isn't it? Yes, sir. Just listen me out. When this much portion of the string comes into contact, then this 2 is going to coincide with this 2 dash over here, isn't it? Yes, sir. And then the remaining portion of the string can be shown by this tangent. Once again, when this much portion of the string comes into contact with the circumference of the circle, then the remaining portion can be represented along this tangent line, isn't it? So you've got to make tangents through all of these spokes, and it's very, very easy. Let me tell you, you just need to keep the smaller scale of your compass, and then the larger scale will automatically point in the direction of tangent this way. Okay, you have to repeat this for 2 dash, 3 dash, 4 dash. I'm sure you guys can implement this very, very easily. Once this is done, now try to realize if this much portion has come into contact with the disk, that means this much portion. Now let me use a different color. If this much portion has come into contact with the disk, okay, this much portion, what is the remaining portion? So the remaining portion is this much. This is the remaining portion, the one in purple. Okay, that is from 1 to B. So what we'll do is, with 1 B as the radius and then with 1 dash as the center, cut an arc, and this is going to give you B1. Can you do this? Yes, sir. And then with 2B as the radius and with this 2 as the center, cut another arc. This is going to give rise to B2. Similarly, you can mark B3, B4, B5, B6, B7, B8, B9, And as far as B10 is concerned, keep one leg of our compass at 10, other leg at B, literally at B, and then with 10 dash as center, cut an arc. Can you see the arc? Here it is. 10 dash as center, cut an arc. That will give rise to B10. And when you make this arc, please make sure that one end of the arc just touches the circle circumference. And that, by the way, or by default, is your point P. Okay. So the construction is done. What you now need to do is you need to join all of these points in proper sequence, and this is going to give rise to a beautiful curve. Although this curve that I've made does not look beautiful, by the way, it's known as an involute. It would look something like this, and the construction work should be very, very light. Also, you need to do some dimensioning also, which I've shown in the next slide. Here it is. This is how, can you see how the construction work looks? Okay, keep it light, grayish, very, very light. Right, so that was the entire description of this problem based on Involute. Mumbai University, I think in the summer session, May 2022, engineering graphics paper, they had a similar problem. There in that problem, the length of string apparently was 120 millimeters. In this case, it is 140 millimeters, but the entire construction process remains same. There, point B was between 8 and 9. If I can recall that properly. If you guys have seen that video, let me know. Right? Thank you. Next problem, question number 4 from the University of Mumbai, is based on a pentagonal pyramid. There are few things that you need to know regarding this solid, a standard solid. This is a pentagonal pyramid. Why? It has got a pentagonal base, and all the corners of the base, they converge at the top. This topmost point is known as the apex. Okay, please remember that there are as many as 5 base edges, and the pentagonal base has got a center. This center, when connected with the apex, creates a line that is popularly known as the axis. And there are as many as 5 triangular faces. Which ones? 1, 2, 3, 4, 5. Right? Okay, all good. I think it would be better if I can show you all of these things in a question paper. Here it is. And for how many marks? It's for 15 marks. And this question deserves 15 marks, to be very, very honest. And it's a very good question to judge a student's ability of orienting the solids in different manners. Okay, let me take you to the main slide, and then I'll demonstrate all of this with the help of my phone camera also. Okay, don't worry. Here we go. So we've got a pentagonal pyramid, side of the base 35 mm and axis 65 mm long, resting on one of its corners on HP, such that the triangular surface is parallel to HP. Someone who has read the question so far, I mean the first 3 lines, would be confused. Okay, one of the triangular face is parallel to the HP. At the same time, it is perpendicular to the VP. How is this possible? It is possible, in fact. I'll let you know. Draw the projections of solid when the base edge containing that triangular surface is parallel to both HP and VP. Again, this entire sentence creates a lot of confusion inside the heads of students, which is why a lot of you are going to let go of this problem and maybe go ahead and attempt some other problem. Okay. And one more thing has been given. The apex of the pyramid is being nearer to the observer. Okay. First thing, the dimensions of the solid, the pentagonal pyramid. Here they are. Base, all of these base edges are 35 mm each. Secondly, this pentagonal base has got a center, and that center, when connected with the apex, forms the axis, which is 65 millimeters long. All the points in a sequence, in chronology, have been written down. First is resting on a corner on the HP. What does this condition mean? This condition means that the case is somewhat in this fashion. Okay, there are as many as 5 corners, and on one corner, let's say this one over here, on this corner it is resting. Let's say if I change the question and if I write it down that it is resting on one of its base edges, then it would have been this way. This is resting on the base edge, this is resting on the corner. I'm sure now you can understand the difference. Now, it is also written that one triangular surface is parallel to VP and perpendicular to VP. Okay, let us try to understand this. One triangular face. They're calling it a surface. I'll call it a face. Don't worry. I'm talking about this triangular face. You have to keep it in such a manner. You have to keep the solid in such a manner that this face becomes absolutely parallel to the HP. Yes, sir. Now it is parallel to the HP. But at the same time, if I extend this face in the, if I extend this face behind the solid, we'll realize that it will intersect the vertical plane somewhere here. And this intersection is going to be 90-degree intersection, which essentially means that it is also perpendicular to VP. Please remember, if any face, if any plane is parallel to HP, it has got to be perpendicular to VP. That's the trick. Okay. So this basically is going to be your step number 2. And step 1, this is what you need to do in step 1. In step 2, you'll do this. Okay. This face will be looking like this. And you are going to make the front and the top view. In step number 3, which is very interesting, please take a look. Draw the projections of solid when the base edge containing that. Let me read this instead. Okay, very precise. Base edge of this triangular face. Base edge of this triangular face is parallel to both HP. How could this be parallel to both HP and VP? Right now, it is this base edge. You can clearly see it is parallel to HP. Isn't it? Yes, sir. It is parallel to HP. But sir, this base edge, when extended behind, you'll see it makes an angle of 90 degree with the vertical plane. Isn't it? Can I show this to you? ये तो मेरे लिए बहुत मुश्किल हो जाएगा. I've got only 2 hands. How do I do this? Okay, still. Let me try. Watch. This base edge I'm talking about. Okay, this is that base edge. This base edge. If you extend this base edge in the behind, it is going to intersect the vertical plane somewhere here. Okay, and you should realize this intersection is going to be at 90 degree. Please look at my finger. It is going to be a 90 degree intersection. Right? Agreed? So right now, the base edge is parallel to HP but perpendicular to VP. What do you need to do? What you need to do is you need to keep this base edge both parallel to HP and VP. How can this be done? Yes, sir, it can be accomplished. Let me tell you. Step 1. Start with the top view and the front view. Step 2. This is what you need to do. Triangular face parallel to HP. Create the top view and the front view. Done. Step 3. You can do it like this. Now the base edge is parallel to HP. It was already parallel to HP. Now it has been made parallel to VP also. No problem. You can also go for this option. Okay. But on reading the question further, there is one more condition which has been given. It says that apex of the pyramid is nearer to the observer. So who is the observer? My cell phone. Okay. So, or you guys are the observer. Let's say the apex is on your side. Okay. This is from where we are viewing the object, and the apex is towards us. That is exactly what has been given in the question. Apex of pyramid nearer to the observer. If I change the question, if the apex of the pyramid is away from the observer, then the condition would be something of this sort. Apex away, apex near. That is exactly. If nothing has been given in the question regarding the apex, okay, nearer or away, then both the options are correct. You can consider the object in this position and then create the final front and top views, or in this position and do the same. I think enough talking. Let us now switch to PowerPoint, where I'll be explaining you all of this with the help of a beautiful animation, and this is going to be very, very interesting. Step number 1. Please remember, what was our step number 1? This was our step number 1. Okay. Step number 1. Let me keep it again. Step number 1. Front view and the top view. Done. Step number 2. Front view and the top view. In the top view of step number 2, you can see as many as 3 triangular faces are visible. 1, 2, and then this one is also visible. Okay. And the edges which are not visible have to be represented using dashed lines. Why? Because they are hidden. Right. Let us focus on step 1 and 2 for now. We'll switch over to step number 3. Don't worry. Here we go. Just a sec. Let me switch on to the presentation mode and here it is. बहुत सारा जुगाड़ करना पड़ता है यहाँ पे, मतलब इतना कुछ समझाने के लिए, है ना. अगर मेरे पास यार थोड़ा सा बजट बढ़ाना पड़ेगा लगता है. वैसे अगर एक कैमरा मुझे ऊपर से मिल जाए ना यहाँ से और एक यहाँ से, तो बहुत बढ़िया तरीके से. यहाँ पे तो खुद ही हैंडल करना पड़ रहा है. एनीवे, let's start by creating a pentagon. Done. Here we go. I'm sure you guys now are well versed how regular pentagons are created. Center. These are the slant edges. Done. Let me have the front view. So the arrow from down to top. Projector lines. And what do you see now? Sir, at the bottom, this base edge will be seen. So dark line. Okay. A will be seen. B, just behind B, there is E. And the same can be, done with C dash and D dash. Okay, so by the way, this is 35. The dimensions were given to us. This is the location of the axis, the bottom of the axis, 65. This is 65. Now connect these three slant edges in one go. Done. In the step number 2, what you need to do is copy and paste, but with some rotation. There is a problem. What is that problem, sir? The problem is, what we need to do is we need to keep this absolutely parallel. By the way, here it looks like this is a slant edge, but this is not a slant edge. This is rather a triangular surface or a face. Okay. O, C, D. Yes, sir. We get this. This line actually represents a triangular face. We got this. And this is that face which will be kept parallel to HP. And obviously it will become perpendicular to VP. You'll realize this. For this, what we need to do is we need to keep this face like this. This is O dash, this is C dash, D dash, and this A dash is a corner. A dash will be here, and these points, this B dash, E dash can be obtained, and then this axis, all of this can be done. But sir, how do we reach step 2's front view from step 1's front view? How can this be essentially accomplished? Easily. We want an easy way. The best way to do is to use your mini drafter. Okay. What we really need to do is we need to keep one scale of our drafter along this triangular face. Done. Tighten the screw. Done. Yes, sir. It is locked into this orientation. Bring it to A dash. Make a line. What does this line do? Sir, this line is actually perpendicular. Now we are going to take advantage of this perpendicular line. Okay. So what we'll do is we'll similarly make a point. Let me call this point as A dash. And then what I'll do is I am going to make a perpendicular line. Now we are going to make use of an arc of a certain radius. What is that radius? That radius is A dash 1. Okay. So with an arc of radius A dash 1 and then with A as center, you need to cut an arc over here. What will you get? You will get 0.1. Can you do this? Yes, sir. Very easy. Now draw a line of this sort. An absolutely parallel line. From 1 to the left of 1, you've got O dash. This is how you get O dash. To the right of 1, you get C dash and D dash. Okay, again with 1 as center, cut an arc again. This is C dash and D dash. Please do this. Here we go. Join C dash D dash with A and O dash with A dash Y. Done, sir. No issues. Okay. As I told you, when you look at it from the top, you are going to see 3 triangles, triangular faces rather. But before that, we want these points as well. How do we get them? So we can take this much as arc and then we can take A dash as center. Cut this. This is going to be our precise location of B dash E dash. Similarly, the foot of the axis. What is this? This is the foot of the axis. This is the head of the axis. You can say so. So the foot of the axis, again with A dash as center, you can cut an arc. This is the foot of the axis. And by the way, this is how it goes. So the front view has been recreated, keeping this triangular face at an angle of, not at an angle, rather it is parallel to HP. And you know very well, I demonstrated it to you that if it is parallel to HP, it is perpendicular to VP. as far as plane surfaces or faces are concerned. Done? All good? Now, what to do? Let's take a look at it from the top. Okay, lines, lines, O dash. This, by the way, is O dash, or not O dash, simply O. Let me. This is. This is simply O. O and O. So that's the location for O. Similarly, this is the location for A and A. That's A. Similarly, this is E and this is the precise location for E. Did I do something wrong? No. Just a sec. This line is meant for B and E. This line is meant for E. So they intersect over here. That's E. This is for B. That's B. I'm sure, you can do this. Here we go. As I told, there are 3 triangular faces that you will be able to observe from the top. If you want, I can show them to you once again. Let me get to my phone. This is what you will see from the top. Let me demonstrate. And try to visualize all of these things in your mind. Okay. So step 2, front triangular face. This triangular face is parallel to the HP and perpendicular to VP. When you look at it from over here, from the top, as many as 3 triangular faces can be visualized. Who are they? This one, then this one, the flat, and also this one. 3 triangular faces can be visualized right from the top. Okay. I hope you have understood this. Here we go. Back in the presentation mode. These are the 3 triangular faces. Whatever is not visible, sir, it is a hidden. That means A to E, B to A, and A to O. Hidden features, hidden edges. That's why we'll use dashed lines to represent them. Done. Done. Coming to step number 3, which is a bit typical. What you need to do is, please follow my steps. This is the apex. Yes. We have been clearly instructed in the problem that while implementing step number 3, you need to ensure that apex of the pyramid is nearer to the observer, and also you need to make sure that the base edge of the triangular face is parallel to both HP and VP. Now the base, in order to make this base edge parallel to both HP and VP, what you guys need to do is you need to do some kind of rotation. Either you can go for clockwise or anti-clockwise, but since we have been instructed that apex should be nearer to the observer, we are going to go for this option. Okay, here, this is the apex. Please note, what I have basically done is, let me write down the numbers 1, 2, 3, and 4. Okay, if you rotate this 90 degrees in the anti-clockwise sense, assume that it is enclosed in a rectangle. This figure has been enclosed in a rectangle, inscribed in a rectangle, let's say. What you guys need to do, you have to work out the dimension of this rectangle. This can be done very easily. It's very simple. You need to recreate this rectangle over here, but at an angle of 90 degrees in the anti-clockwise sense. Done. You can locate this point O very easily. It is right at the center of the smaller edge. So this basically is 1, that's 4, that's 3, and that's 2. Very easy. Okay, so then somewhere along this line, you are going to find point A, O, A, O, A, somewhere here. Let me show this to you. Yes, sir. Very easy. Now what? So, but what if we want the location of E? That can be worked out very easily. Let me demonstrate this to you. From 1 to E, you need to take an arc of this much radius, 1E. Now, with 1 as the center and with 1E as the radius, you need to cut an arc. It will cut somewhere here, and this is going to be the precise location of point E. In the same fashion, you can obtain all of these points taking references of these 1, 2, 3, 4. Okay, I hope you got this. So basically, we have recreated the top view from step 2 to step 3. Okay, and if I just place an arrow over here, this is us. We are the observers, and this apex is towards us, and that is exactly what has been asked in the question. Please remember, we were instructed that apex of pyramid, okay, it is nearer to observer. Base edge is parallel to both HP and VP. If a line is parallel to both HP and VP, that means its front and top view will be both parallel to the XY line, and that eventually will will be observed when we make the final diagram. Right now you can see this is the triangular face I am talking about. Okay, this CD. Right now CD is perpendicular. Yes sir, perpendicular to VP. But this CD, C dash D dash, C is also at the same height. D is also at the same height, which essentially means this CD is parallel to HP, but this CD is also perpendicular to VP. Where do you find it perpendicular to VP? Here sir. Where do you find parallel to HP? Here sir. I demonstrated it to you. Okay. Now what you can do is project all the lines, find the intersection points. What you see finally should look something like this. Let me demonstrate this to you. Here we go. चलो देखते हैं इसको. आजा भाई इधर. Okay, where is the object? Here it is. अरे 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 भाई. Take a look. Step number 1. Okay, what you need to do is, since the true shape of the base can be seen from the top, therefore we started by creating the top view. Step number 2. This triangular face parallel to HP but perpendicular to VP. This base edge, it is parallel to HP, agreed, but it is perpendicular to VP. So in step number 3 we'll do this. Now it becomes parallel to both HP and VP. Okay, so if you watch, this is your step 3. In step number 3, this triangular face over here, it appears as if it looks like a line. This triangular face instead looks like a line, isn't it? How many other triangular faces can you observe? Sir, 1, 2, 3 and 4. These are the 4 triangular faces that you guys can observe. Already we are 20 minutes down the line, and I think it's time to wrap it up. Here we go. Here we go. Four triangular faces. This looks like a line. Done. The 4 triangular faces are, here they are. This is how it should finally look. Okay, and as far as the dimensions are concerned, let me put them. And also the construction work should be light. It should look finally something like this. This should be the level or accuracy of your work that is expected. If you can achieve this much accuracy, I'm sure you can get 15 marks. The teacher, the examiner won't be hesitant one bit to give or to reward you with 15 marks. I'm very much sure. Right? Your work should be absolutely neat and clean. Neat and clean does not mean कि sheet को खाली छोड़ के आ गए. Wherever there are solid lines, you should use an H pencil. Wherever there are construction lines or projectors, you should use a 3H or a 4H pencil. Okay, so yes, that was the entire solution. I'm sure now you are in a very good position to go ahead and you'll be able to create this drawing manually on your drawing sheets. Okay, thank you. Question number 5. This is from one of my favorite chapters, favorite topics, that is projection of lines. Please note, as long as the line stays in the first quadrant, there is absolutely no issue. You will be able to make its projections. That is both the front and top view. The moment line or the end point of the lines changes quadrants, let's say end point A is in the first quadrant, end point B is in the second quadrant or in the fourth quadrant, there is an issue. People find it difficult to visualize it inside their head. But I have already given all of you guys a template which you can follow and easily make the projections. Okay, does not matter whether you are able to think about the positioning of the line in 3D or not, you still would be able to draw its projections. So make sure you watch this video till the end. This is going to be super interesting. Okay, and there are many more such problems. In this case, it's something like this. The endpoint P is in the HP and at a distance of 25 millimeters from VP, whereas this endpoint Q is in the VP and 50 millimeters below VP. Okay, you must have seen this kind of a quadrant, the two-dimensional coordinate system, in your school, isn't it? This basically is a three-dimensional coordinate system, and it's a lot of fun. Here we go. I think it would be better if we start by reading the question, and let me just open the slide. Where is it? Yeah, for 15 marks, one end P of a line PQ is in HP and 25 mm in front of VP. Okay, in the HP and 25 mm in front of VP. Fine. While the other end Q is in VP and 50 mm below HP. It is in the VP and 50 mm below HP. Case of fourth quadrant. Draw projections of line PQ. Find its inclinations with HP and VP. That means theta and phi both have to be calculated. If the true length of the line is 70 millimeters. Wonderful. So we are going to initially write down all the data which have been given in the problem. So first of all, let us talk about endpoint P. Where is it lying, sir? It is in the HP. And how far is it from the VP, sir? It is 25 mm in front of the VP. So the point happens to be a case of the first quadrant. Okay, so you all know distance from HP is represented by H, whereas distance from VP is represented by D. If you are not aware of these notations, go ahead and watch my videos on projection of points. They are going to help you a lot. If this is the case, then it is a clear-cut case of a line being in the first quadrant. And when I say first quadrant, H above, D below, that means front view above, top view below, P dash and P. This is how things are going to span out. Okay, this is going to be basically the XY line. Second, endpoint Q. It is in the VP. If it is in the VP, what is its distance from the VP? So its distance is obviously going to be 0. That means D is going to be 0 for point Q. Okay, and it is 50 mm below HP. So I have written that down. No problem. Let's try to visualize this point. It is a clear-cut case of fourth quadrant. Okay, and if it is fourth quadrant, then H and D, both of them will be below the XY line. Front and top view both are below the XY line. So is Q dash and Q. Right. This is going to be our representation for point Q. So far, so good. The third thing is we need to work out theta, phi, if the true length of PQ is 70 mm. So I've written that down as well. Okay. Time to visualize the problem in 3D, and this is going to be very interesting. Discard. Here we go. Where is the okay, that's my AutoCAD file. Hanji, take a look. It's a very interesting case. And first of all, let me stay out of the way. Now take a look. This is the line. Point P is in the HP and 25 millimeters in front of the VP. Take a look. And this is point Q in the vertical plane and 50 mm below. If you want to take a look at it from this side, so this is point P, 25 in front, and in the HP, this is point Q in the VP and 25 mm below the HP. So this is how the line is positioned. What we need to do is we need to make its projections, and also we'll be calculating the angles the line makes both with HP and PP. If you want to take a look how the projectors would look, take a look. बहुत सारे look हो गए. Anyway, so just see here. This is point P. When you observe it from the front, this is its projection. Okay, since it is on the HP, therefore the front view is going to lie on the XY line. You can see that. Second, the top view is always formed on the horizontal plane, and you can see when you look at it from the top, this is the top view. So that is for point P. As far as point Q is concerned, point Q's front view, you know very well, it is a case of vertical plane. So it is right here. And as far as top view is concerned, you just need to look at it from the top this way, and you have to project it on the horizontal plane. That's how you see it. This is going to be Q. Now, the interesting thing is, when you join P dash with Q dash, this is what you see. Okay, the line in green represents the final front view, which apparently makes a angle alpha with the XY line. Secondly, the top view, when you connect P with Q, that is going to be your top view, and this is how it would look. The one in this aqua color or cyan. Okay, are we good to go? So this is how the actual arrangement is, and I am very much sure, even after watching this arrangement of the line in 3D, most of the students would fail to create edge projections on a plain sheet of paper. That's a fact. It's a complicated question, but with the help of the template, we are going to find an easy way out. Okay, so I want all of you to focus absolute attention for the next 5 minutes, and we are going to crack it very, very easily. And there are similar problems that could be constructed in different quadrants. So it's very important that you have a thorough understanding of such things. Take a look now. Take a look. Please remember, point P in the HP, 25 in front of VP, H and D given. Point Q in the VP and 50 mm below HP, true length is given to us. Okay. All right. So this is something that I have already discussed in my lectures long time back. Okay, the ones who are following this channel, a lot of students have even passed, right? Students who were initially connected to me via YouTube have now connected to me by LinkedIn. So they're working in MNCs, and I mean, they're doing pretty good in their life. I wish them all the best. Yeah, anyway, so this is something that I'm going to provide in my notes also, don't worry. Okay, just take a look. Please remember this template. If you want, you can take a screenshot. Now, in our problem, our line is named as or represented by PQ. So wherever there is A, there is P, where there is B, there is Q. Please remember. Let me zoom in slightly. It's very important that you note all of these things. This is the locus of B in front view. Whatever there is in the vertical plane, it's front view. Whatever there is in the horizontal plane, it's all about the top view. Okay, this is locus of A, or in our case, it is P, locus of P in top view. This is locus of Q in top view. Please remember. Okay, this is the true length, A dash B1 dash, right? That is P dash Q1 dash is the true length. Similarly, PQ2 is the true length. P dash Q dash is the final front view. PQ is the final top view. This is what we want. P dash Q dash and PQ, final front and final top views. Apart from this, P dash Q1 dash is also very important to us because it will help us calculate this value of theta. So watch this video very, very carefully. We are going to start by first of all drawing the projections of point P. Point P's front view is on the XY line. H is 0. You know that very well. So here it's point P dash. Top view, D is below, 25 below. Go ahead and join it. Okay, so this eventually becomes locus of P in front view, locus of P in top view. Sir, how far is the projector of Q from P? I don't know. Okay, and I don't give a damn either. What I'm going to do now, we know very well that Q is, when you look at it from the front, okay, Q is 50 mm below the HP, isn't it? The front view of Q will be 50 mm below HP. So 50 mm below, simply make a line. This is where the front view of Q is going to lie. Where is the exact location? We are yet to figure out. Don't worry. So I've written locus of Q in front view. Okay. Please make, this is very important. If you write locus of Q in top view, sab gadbad ho jayega. Right? Nothing will fall in place. And you know very well that Q is a point in the vertical plane. If it is a point in the vertical plane, that means D is equal to 0. Okay, which essentially means its top view is going to lie on the XY line. So its top view is going to be somewhere here. Locus of Q in top view is here. I don't know the location where, but somewhere here along this line. Okay, So far so good. What is the next thing that you'll do? Sir, let's refer to this template and let's crack the true length. True length is 70 millimeters. How can you get the true length with theta immediately? We can get that. What you need to do is, let's take a look. Take a look. This is the true length. Okay. Locus of Q in front view. So what you can do is you can take P dash as the center. Listen to what I say. Maybe you need to watch the videos 2 to 3 times. I'm not going to be repeating. Take P dash and center and cut an arc. Arc of 70 millimeters. That is the true length. Okay. On the locus of Q in front view. Right. With P dash as center. Put an arc of radius 70 millimeters on the locus of Q in front view. Let me do that. With P dash as center, right? And on the locus of Q in front view, you need to put an arc of 70 millimeters. Done. Here we go. This is Q1 dash. Connect. That's the true length. True length. And this, by the way, you guys can calculate, do the measurement. This is theta. I'll write the answers over here when the complete projection finishes. That's the first thing. Second thing you can do, refer to this template again. Now with P as center and with 70 millimeter as radius, you need to cut another arc. This is going to help you get the Q2. Okay, with P as center and with radius as 70 millimeter, cut an arc again on the locus of Q in top view. Where? On the locus of Q in top view. Okay, so with P as center, cut an arc again on the locus of Q in top view. This arc is having a radius of 70 millimeters. Join. This, by the way, is your angle phi. You can do the measurement using a protractor. Now what, sir? Now comes the time where we are going to refer to this template again. So we have access to Q1 dash. We have access to Q2. Yes? Okay. So from Q1 dash, you need to drop a perpendicular until it reaches the locus of P in top view. Until it reaches from Q1 dash, you need to drop a line or produce a line, a vertical line, until it intersects the locus of P in top view. From Q1 dash, you need to produce a line until it intersects the locus of P in top view. Here it is. This is Q1. Now, again, refer to the template. So we have basically reached here. Okay. And now with this much as the radius, I am going to rotate with respect to P as the center until it intersects the locus of Q in top view. Rotate until it intersects the locus of Q in top view. Rotate until it intersects the locus of Q in top view. Locus of Q in top view. Right? This is point Q. Connect Q with P. This is your final front view, and this angle right here is what is known as no. This is your final top view, no dash. Okay, final top view, and this angle over here is what is represented as or represented by beta. Done. Okay, so far so good. You can also project it downwards, like this P dash and P are on a same vertical line in the same fashion. If this is Q, this has got to be Q dash. Okay, there is another way also. What you can do is listen. Take a look at B2, that is Q2. Produce Q2 until it intersects. Listen to what I say. Produce Q2 until it intersects the locus of P in front view. Produce Q2 until it intersects the locus of P in front view. Here we go. Produce Q2 until it intersects, where downward or upward? Until it intersects the locus of P in front view. So P, locus of P in front view is here. Where are you going to produce it? Above, below? No, it is right here on the same on the same horizontal line. So Q2 dash is going to be here. Okay, like Q2, and this is Q2 dash. Here it is on that same horizontal line. Now things are going to become very easy for you. What you need to do is you need to take this much as the radius in your compass and then rotate until it intersects the locus of Q in front view. this way. Okay, until it intersects the locus of Q in front view. Here it is, locus of Q in front view, and that's Q dash. Connect Q dash with P dash, and this basically connect. This is the final front view. The ones in red, final top view. This red, final front view. This is true length with angle phi. This is true length with angle theta. Right? All the values have been mentioned over here. I'm sure you all can crack this easily. There is a method to this madness. Let me tell you very honestly. There, I mean, it's good if you try to think about this problem in 3D, but I believe that there is a problem. I mean, there is an issue. Everybody cannot think of a line in 3D. It is difficult. When this is the case, you can use such methods. Use the template and crack the problem. On to the final question. In this question paper series from the University of Mumbai, the subject is engineering graphics. Here we go, problem 6a. Let's try to crack this. So we've been given the front and top view of an object, front and the top view. Draw the isometric view of the object. It's a very easy problem, let me tell you honestly, and you can crack this in the next 5 to 10 minutes. Very easy. Okay. Let's study both the front and top view simultaneously, and we'll try to figure out the maximum length, width, and height. Here we go. Just take a look at this. What is the length? Sir, the length happens to be 70. What is the width? Sir, it is 30. So we are going to initially kick off by simply marking a point, and then length. You can do the length over to this side or this side as your choice. So I am opting 70 millimeters over to the right hand side, and please make sure this is at an angle of 30 degrees. At an angle of 30 degrees. Okay, please make a rough sketch, something like this. Just a sec. This way. This is the isometric axis, and you've got to move your scale along these lines, parallel to these lines, because you are making an isometric drawing. That is the reason. The best way to create such lines is, first of all, to make two lines at an angle of 30 degrees with the horizontal. When you do that, since this is 90, automatically this angle becomes 120, and this angle also becomes 120, and you are left with 120 degrees, so that you can say that's 120. This is also 120. This also is 120 degrees. So equal angle isometric. That's the meaning of the term. Sir, how should we proceed from here? This is 70. This is 30. Done. Now what? Keep your drafter parallel to this line. Done. Tighten the screw, bring it over here, and draw a line. In the same fashion, repeat the same for this line also over here. Done. Sir, the height has been given as 10 millimeters. So we are going to initially build this platform, and once this platform is created, I'm going to then go for this profile. Here we go. Let us give all the four corners a height of 10 millimeters. Join all of these points. What I wish to do next, I want to remove these edges as they fall directly below the top face. Let me remove them. Okay, just to make sure that you guys don't get confused. Right? There are going to be so many lines. It is possible that there may be some confusion creeping inside your head. Okay, now what? Now you need to take care of this very point. I am going to make this rectangle. This rectangle is 40 by 20. Again, how much? Sir, this is 40. You can see this. This is 20. You can see this. How do we locate this point? Can be done very easily. This in totality is 70, out of which this much is 40. 70 minus 40 gives you 30. That means half of that 30 will be here. Another half will be here. So that's 15 and 50. Secondly, what is the distance between these 2 points? Can you work it out? Yes, sir. 30 minus 20 will give you 10. That means half of 10. That is over here is 5. And the remaining half is here 5. So what you need to do is, let me zoom in. with respect to this point, travel 15 millimeters to the right and then travel in the upward direction by a distance of 5 millimeters. Can you do this? So we've got this point over here, 15 and then 5. This is, yes sir, 15, and this is, sir, this is 5. So we've reached here. Okay, let me erase all of these things. So far so good. Now sir, this is 40, 20, 40 and 20. So let me make this rectangle in the isometric drawing. 40, 20, 40, 20. Done in one go. Okay, please make sure that these lines are absolutely parallel. These all are isometric lines. If you watch, there is this peak right at the center. Okay, so I'm going to be making these 2 points with the help of a simple line. I am basically interested in these 2 points, and through these 2 points I'm going to give them a height of 35 plus 35, which happens to be 70 millimeters. If you watch carefully, if you say this is 1 and this is 2, so this over here is going to be 1 dash and 2 dash. You can also say this is 1 and 2. So 1 and 2, both of them will be given a height of 35 plus 35, that is 70, and here we go. Okay, so connect these two, although some portion in the middle has to be chipped off later. Don't worry, we are going to do it. And now you can join these 2 points and these 2 points. Here we go. Done. By the way, you have to do all of this construction using a 3H pencil and even hold it very lightly. Construction should be barely visible. Okay. Sir, what about this dashed line? What is a dashed line used for? So it is used to represent hidden edge. So there must be some hidden edge. This is that hidden edge, which you guys aren't able to see from the front. Okay, from over here. So as of now, I'll make that edge over here. Its exact location will be worked out, don't worry. And now let's how much was this, sir? This is 5, sir, this is 10, and sir, this is again 5. 5, 10, 5. So from both of these locations, 5, 10, and once you enter 5, you're going to reach here exactly. Okay, now you go for joining these points. Join this way, and then you can connect, join, right? Again, when you make these lines, they have to be parallel to this line over here, which is a non-isometric line. So make use of the mini drafter. Keep your drafter parallel to this line, aligned along this line, tighten the screw, bring it over to this point and this point, and draw these 2 lines. And same is the case with these 2 lines also. Your drawing is done. Okay, let me show you the magic. Once the portion is which is going to be visible to you is this. This is the portion which will be visible to you. Okay, as far as this hidden feature is concerned, this hidden edge, this is that hidden edge I'm talking about. This is that edge. Okay, I'm sure you now have a good assessment as to how go about your task as far as this problem is concerned. That's it. It's over. Isometric projection done and dusted. Okay, so damn easy. 8 marks in your kitty. All right, see you in the next problem. Okay, here we go. On to the final question of this problem series from the University of Mumbai. Question 6b, which is for as many as 7 marks. This is going to be very interesting, and it is based on the chapter projection of solids. And the solid we are going to deal with happens to be a hexagonal prism. This is a hexagonal top. That's a hexagonal base. And these are the edges which connect the base to the top. And you can also say that it is surrounded by rectangular faces. How many? 6 in number. 1, 2, 3, 4, 5, 6. It would be better if I can switch to the slide mode and let's read the problem's description. And here we go. Where is it? Here it is. Okay, let's read it first of all, and then let's try to work out the details. Here it is. So there is a hexagonal prism, side of base 35, axis 65, resting on one of the base edges. Very important point, resting on one of the base edges on HP such that the base of the prism is inclined at, look here, the base inclination has been given. in most of the problems, in 99% of the problems, you'll see that the axis inclination is given either with respect to HP or VP. Here, this is slightly different. Base of the prism, okay, base inclination has been given as 45 degrees to the HP. Axis being parallel to VP, draw the projections of the prism. Let me tell you from the outset, this is a very easy problem. You can crack this in the next 10 minutes, and I'll try to deliver in 10 minutes only. Here we go. Let me write down all the details which have been given in the problem, and here they are. What are we talking about, sir? We are talking about a hexagonal prism. Here it is. Okay. Secondly, this prism has its base edge on the HP. This is the condition. Please make sure it reflects in your orthographic projection. Secondly, the base of the prism is at an angle of 45 degrees with respect to the horizontal plane. Okay, and the axis being parallel to the vertical plane. Fair enough. If the base is inclined at an angle of 45 degrees, then automatically you can say or make this conclusion, draw this conclusion that the axis also is at an angle of 45 degrees. Now, this is something that I have taught you in my earlier classes, that let's say if axis inclination is theta, then the base inclination is going to be 90 minus theta. And here it's the other way around. You have been given the base inclination, though therefore the axis inclination is going to be 90 minus theta, vice versa. Okay, so don't worry. We are going to in fact incline the base only and not the axis, right? I think with that being said, let me take you to my cell phone mode and let me now show you the object. And let's make this writing pad in the form of a vertical plane. Okay, so this is our object. We'll keep it in the standing position for step number 1. The condition which has been given in the problem is that the base edge, this basically is the base, top, center, this is the top, center at the top, center at the bottom. When you connect these 2 points, that line is an axis whose length is 65. All of these base edges are 35 millimeters long. Okay, so this was about the dimension of the object. In the question, it has been clearly mentioned that one base edge is on HP. So take a look. This base edge over here, this base edge is on the HP, isn't it? If I change the question and if I write that one corner is in the HP, then it would have been in this fashion. This corner is in HP. Now, since we have been given the base edge is on HP, this is your condition. And this base makes a certain angle with the horizontal plane, this base, which looks like a line from over here. This base looks like a line in the front view. So you have to keep this line at an angle of 45 degrees, which essentially means the base will automatically be inclined at 45 degrees. Okay, that's the idea. This is your step number 2. Step number 1. Step number 2. Step number 1. No inclination of the base. Okay, it is resting with its base on the HP. In step number 2, we are going to incline the base. And then we are going to create the top view also. For step number 1, please, what are you going to draw first? Top view or the front view? Sir, we are going to create the top view first, because the true shape of the base, okay, the true shape of the base or the top can only be seen from the top view. Therefore, we are going to begin by creating the top view first. And simultaneously, after that, we will be creating the front view. That step number 1 is over. And this is going to be your step number 2. What is step number 2? Sir, this base will be inclined at an angle of 45 degrees. This is step number 2. Very easy. And in this position, we'll be creating, let me bring it closer. We'll be creating its top view. This is what you see from the top. This sort of compressed, sort of laterally compressed hexagon is what you'll see. And these 3 rectangular faces, it's 1, 2, 3 rectangular faces will be seen. And also, I wish I had more hands. I could have explained and demonstrated you in a much better fashion. But don't worry, we can work it out. The remaining stuff in the drawing itself. Okay, here we go. Question number. Let me switch to the presentation mode. Okay. Here we go. Where is my writing pad? Okay. what are you going to do? Sir, we are going to draw a hexagon. I'm sure all of you guys know how to make a hexagon like this. The internal angles are, what are they? 120 degrees each. Okay. So there are 6 corners at the base, which we are going to represent by alphabets, and the 6 corners at the top will be represented by numbers. So these are the corners for the base. These are the corners for the top, right? Let me take a look at this from the front. Let me have the projector lines. This is at the bottom. At the bottom, we are going to have 6 corners in the form of alphabets, like A, behind A there is F, B, behind B there is E, similarly C, and then behind C there is D. In this fashion, you need to write it like this. And by the way, this hexagon, all the sides are equal. This is 35 millimeters. Secondly, the height of the prism is 65. Okay, height is equal to the length of the axis. That's 65. Right? I'm going to be doing the dimensions, don't worry. The top 6 corners. Now 1, behind 1 there is 6, behind 2 there is 5, behind 3 there is 4. Let me write all of them. Tons of. In the second step, what we'll do is we are going to copy and paste, but with some rotation. So you have to recreate this front view from step 1 into step number 2, but with some rotation. You know what that rotation is. This edge will stay in contact. As mentioned in the problem, one edge is in contact with the HP, but at the same time, the base is going to make an angle of 45 degrees with the horizontal plane. So what we'll do is we'll make a point. Okay, and this is the base. This has got 6 corners. Please note, you have to recreate this edge over here at an angle of, this angle is, by the way, 45 degrees. And okay, sir, we can do this. How can you mark where exactly B dash E dash is? Again, with the help of a compass. With this much as the radius, with a center, you can make this arc over here, and this intersection point will give you B dash E dash. I'm sure that you can work out C dash D dash on your own. Okay, there is not going to be any spoon feeding anymore. So when you have got these points, then what you need to do is keep your one scale of your drafter over here. Okay, this way, tighten the screw, bring it over to A dash F dash, draw a line, bring it over to B dash E dash, draw a line. In the same fashion, draw a line from C dash and D dash. Done. Finish it off. Now watch it from the top. Draw the projector lines in the downward direction and the projector lines towards the right. What do we need now? So we need the intersection points. Like this vertical line has got point 1 and 6. Exact location of 6 is here. That's 6 for you. And the exact location of 1 is here. In the same fashion, the remaining points, I'm sure you guys can work it out on your own. What is left? As I told you, this hexagon is clearly visible to you from the top directly. Okay. So make it. Secondly, edge 3 to C. This edge over here is visible. Yes, sir. Edge 4 to D is visible. Edge 3 to C is visible. 2 to B is also visible. B to C is visible, sir. DC is visible. DE is visible. Okay. Since they are visible, let me make them using solid thick lines this way, and whatever is left should be drawn given respect with the help of dashed lines as they are hidden this way. Okay. And if you want to see the construction work, how light it is, here it is along with the dimension. Done. So this is the level of accuracy. This is how your drawing should look finally. I'm sure you guys can crack this very easily. It's a relatively easier problem. So question number 6A and 6B, both of them were easier problems. I hope that whenever you see or whenever you come across easier questions in your question paper, solve them, crack them. Okay, don't let them go. Don't go for tougher problems. If you have the choice for an easier problem, go for it. Okay, so that was all from my side as far as Mumbai University's 2022 December question paper is concerned. I think I have put in my best efforts to craft best videos for all of you. And this video is available in my application and also on my YouTube channel. The one shot video is something that I'll be preparing next. Don't worry. And as far as the entire PDF solution is concerned, it will be made available on my application. You can open my application. By the way, first of all, you need to download it. The link for that is in the description down below. Go ahead, download, install the application, and Inside the engineering graphics course, there is a special university wise folder. Go inside it, you will find MU folder, Mumbai University folder, and inside that you are going to have your access. I've kept this PDF unlocked for all of my students from my YouTube family, so go ahead and take a look at all these solutions. Okay, so this is going to really help you as far as examinations are concerned. And please let me know what is the exact date of your paper, MU paper, Mumbai University paper, and so that we can also plan some other things, maybe a mock paper, maybe some strategizing, which chapters are important, right? This is all on you guys. You have to let me know about these things. So yes, that was all from my side. This is Manas Patnaik signing off. Take care. Have a nice day. Thank you.